Okay, here is the entrance slip that we did today. Gold will dissolve in the acid mixture known as aqua regia according to the following reaction. Now, anytime you're given a reaction, you need to first of all look to make sure that this is balanced. And this is a balanced chemical equation. How many, and I switched it up a little bit, the wording, how many moles of water will be produced in this reaction when one starts with 1.55 moles of gold? How many moles of hydrochloric acid must be added initially to dissolve all of this gold? So basically, we're just reinforcing our mole to mole relationship, our molar ratio, as we call it. So, this is a two-part question. We'll have two answers. First, I'm going to find how many moles of water. I'm going to take what's given to me, 1.55 mole of gold. I'm going to make my conversion box, and I'm going to need the molar ratio. Well, where do I get the molar ratio? From the balanced chemical equation. All right? So, I know that I want gold to cancel, right? Moles of gold to cancel. Well, how many moles of gold do I have up here? One. One mole, AU, which is gold, and I want to get this into moles of water. Well, how many moles of water do I have up here? 2. I get my moles of gold to cancel. My final label is going to be moles of water. So I take the 1.55, I multiply it by 2, and I get 3.10. I need the 0 to have 3 significant figures. So all I need to do is get the molar ratio from the balanced chemical equation. Now for the second one, I am trying to find moles of hydrochloric acid. So I'm going to start with the same thing, 1.55 mole of gold. Once again, I'm going to need to go to my balanced chemical equation. Well, I know that my 1 mole of gold hasn't changed. Okay, it's still 1 mole up here. I want to convert this into mole of hydrochloric acid. How many hydrochloric acids do I have? 3 mole. Get a cancellation. Yes, I do. So when I do my math, I'm going to come up with 4.65 mole hydrochloric acid. Questions for me? Because we're going to need that molar ratio a lot today. Okay, we're going to need that today also. So go ahead and take out or open up your notes. We're going to start today dealing with mass-to-mass problems. Okay? Mass-to-mass problems. They are difficult. So I am going to give you a step-by-step process for you to solve these mass-to-mass problems. And we're going to start with step number 1. Step number 1 is to determine the reactants and products of the reaction. Write a skeleton equation. This, folks, probably some of this will help you with your lab today also, finding that balanced equation. So the first step is to determine the reactants and the products of the reaction, write a skeleton equation. Second is to make sure that you have balanced the equation. The third step is to determine the known and the unknown quantities. So, what was given to me in the question, that is the known, and what is asked of me to find, that is the unknown. So what the question is giving me and what I need to find, the known and the unknown quantities. The fourth step is to determine the molar masses of the known and the unknown substances. Fifth step, and here's where actually we're getting into the work of the problem. The fifth step is to convert the mass of the known substance to moles. You're going to see that this right here, all that is that's a flux capacitor move. Mass to moles. So convert the mass of the known substance to moles. Step number 6 is to convert from moles of a known to moles of the unknown by using the molar ratio. That is what we just did on the entrance slip, going from moles of a known substance to moles of an unknown substance, using the molar ratio. Once again, just to review, where do we find the molar ratio? Huh? A balanced chemical equation is where the molar ratio comes from. The next step is convert from moles of the unknown substance to mass of the unknown substance. Now those are the 7 steps that you're going to need to do this mass to mass problem. I'll give you a second to write down this equation. So go ahead and write this down. Okay, the question states, tin 2-fluoride is used in some toothpaste. It is made by the reaction of tin with hydrogen fluoride according to the following equation. Sn plus 2HF yields SnF2 plus H2. How many grams of SnF are produced from the reaction of 30.0 grams of HF with Sn? So, basically here's the heart of the equation. Step number 1 told me to write the equation. Step number 2 told me to balance it. Okay? Now, I didn't have to predict anything because it was given to me. Okay? Did I have to balance anything? No. I checked and this is a balanced chemical equation. So what does step number 3 say of the problem? Okay? Step number 3 tells me to do what? Determine the known and the unknown quantities. What is the known quantity? That I have 30.00 grams of HF, right? What is my unknown? Grams of SnF2. So, I'm going from mass of HF to mass of SnF2. Step 3 tells me to do what? Or step 4 tells me to do what? Determine the molar masses, correct? You know how to do that. I'll give you a second. Go ahead. Determine the molar masses of those 2 substances. Okay. The molar mass of hydrogen fluoride was what? Well, it's close, but that's not what exactly. Is that what you guys got? HF. Okay. HF. 20.00634 grams per mole. What about tin 2-fluoride? Okay, that's what I got. 156.7068. We do not use the balanced chemical equation to determine the molar mass. Okay, only HF, not 2HF. Now, we've got the materials that we need to construct this problem, to construct our response. So, step number 5 tells me to convert the mass of a known substance to moles, correct? What's my known substance? .00 grams of HF. Now, this step is just a flux capacitor step, folks. Okay? It's just a flux capacitor step. So, if you want to take out your flux capacitor, you can. You probably don't need to, but what am I going to use as my conversion factor? Okay, obviously I want what to cancel? What of HF? Grams of HF to cancel. So I just calculated that. 20.00634 grams HF. I just calculated that, right? That's the molar mass. That is the mass of how many moles? 1 mole. Now that's a key part there, folks, right there. And I'm going to tell you why. I'm going to tell you why and what you're going to screw up, because this happens all the time. You know what people want to put right here? They want to put 2, because that's the balanced chemical equation. Where do we use the balanced chemical equation? Only for what? The molar ratio, which is the next step. Okay? Because this is not a true statement. This is not a true statement right here if I would put 2. Because 2 moles is not equal to 20.00634, is it? Okay? 2 moles would be equal to 40-something, right? Now, my next step, and I don't have to do the math, okay? I don't have to do the math yet. I can do it at the end. My next step is the molar ratio. So I'm just going to add another box onto it. What do I want to cancel now? I've got to cancel here, right? I've got to cancel here. So I've converted this into moles of HF. My 6th step tells me to convert from moles of a known to moles of an unknown using the molar ratio. So this step, number 6, is where I use the balanced chemical equation. Okay? I have mole of HF is what I have, and it is how many? 2 mole of HF. What am I going to? What is my unknown? SNF2, right? How many mole do I have up there of it? 1 mole. Okay. Do I have a cancellation? Yeah, my moles of HF, moles of HF. So now I have converted this successfully into what? Moles of SNF2. Now, what does step 7 tell me to do? Convert the moles of the unknown to mass of the unknown. What is that? That's another flux capacitor. So I'm going to put another box on here. What do I want to cancel? Moles of SNF. So I know that 1 mole of SNF2, and I calculated that mass, didn't I? It was 156.7068 grams SNF2. So I get my mole SNF2 to cancel. So what's my final label? Grams SNF2. So what I need to do is I need to multiply by all of my values that are on the top and divide by all the values that are on the bottom. It's going to be more than 1, isn't it? Okay, we have multiple values. Here? Yes, that's SNF2. It's tough to read. I was running out of room. Now, how many sig figs do I have? How many sig figs do I have? I have 4, don't I? Okay, so make sure you're aware of that. So, when I come up with my final answer, everything on the top is multiplied. Here's what I do. Okay? Here's what I do on my calculator. And I don't need to multiply by 1, so I take 30.00, I times it by 1, times it by 1, times it by 156.7068. Gives me a value. I divide that value by 20.00634. Gives me another value, and then I divide that by 2 because I'm dividing by everything on the bottom. Divide by the bottom, okay? And you should get 117.4, yada, yada, yada. Okay, actually I got 4.9 on my first one. I don't know why it was different. Oh, okay, I calculated my second part wrong. Should be 117.4928548. Yeah, Garrett? By 2. Right. You should be able, if you go along, folks, if you take it step by step by step, okay, it should come out the same also. So I've got 30.00, okay? The first number I come into here is 20 on the bottom. So I could divide that by 20 to get a value. Then the next step, I'm going to have to divide by 2 to get a value. And then the next one is 156.7068. And I get the same value. So you can go step by step also. And I know this is going to be confusing until you get the hang of it. Okay, this is probably the most difficult part. Okay, this is probably the most difficult part of anything that we've done this year. That's why I give you a step by step by step by step of how to do it. Okay, I'm going to put another example up here. Go ahead. What I would like for you to do is I would like for you to do the first 3 steps of our mass to mass. So write down the question. You have the equation. Make sure it's balanced and get the molar masses. Once you're done with that, then we'll head on and work the problem.